do a reading of A Universe from Nothing by Lawrence Krauss. Chapter 1. It was a dark and stormy night. Early in 1916, Albert Einstein had just completed his greatest life's work, a decade-long, intense intellectual struggle to derive a new theory of gravity, which he called the general theory of relativity. This was not just a new theory of gravity, however. It was a new theory of space and time as well. And it was the first scientific theory that could explain not merely how objects move through the universe, but also how the universe itself might evolve. There was just one hitch, however. When Einstein began to apply his theory to describing the universe as a whole, it became clear that the theory didn't describe the universe in which we apparently lived. Now, almost 100 years later, it is difficult to fully appreciate how much our picture of the universe has changed in the span of a single human lifetime. As far as the scientific community in 1917 was concerned, the universe was static and eternal, and consisted of a single galaxy, our Milky Way, surrounded by a vast, infinite, dark, and empty space. This is, after all, what you would guess by looking up at the night sky with your eyes, or with a small telescope, and at the time, there was little reason to suspect otherwise. In Einstein's theory, as in Newton's theory of gravity before it, gravity is purely attractive force between all objects. This means that it is impossible to have a set of masses located in space at rest forever. Their mutual gravitational attraction will ultimately cause them to collapse inward and manifest disagreement with an apparent static universe. The fact that Einstein's general relativity didn't appear to be consistent with the then picture of the universe that was a bigger... The fact that Einstein's general relativity didn't appear consistent with the then picture of the universe was a bigger blow to him than you might imagine, for reasons that allow me to dispense with a myth about Einstein and general relativity that has always been bothered me. It is commonly assumed that Einstein worked in isolation in a closed room for years, using pure thought and reason, and came up with this beautiful theory, independent of reality, perhaps like some string theorists nowadays. However, nothing could be further from the truth. Einstein was always guided deeply by experiments and observation. While he performed many thought experiments in his mind and did toil for over a decade, he learned new mathematics and followed many false theoretical leads in the process before he ultimately produced a theory that was indeed mathematically beautiful. The single most important moment in establishing his love affair with general relativity, however, had to do with observation. During the final hectic weeks that he was completing his theory, competing with the German mathematician David Hilbert, he used his equations to calculate the prediction for what might seem an obscure astrophysical result. A slight precession in the perihelion, the point of closest approach of Mercury's orbit around the Sun. Astronomers had long noted that the orbit of Mercury departed slightly from that predicted by Newton. Instead of being a perfect ellipse that returned to itself, the orbit of Mercury precessed, which means that the planet does not return precisely to the same point after one orbit, but the orientation of the ellipse shifts slightly each orbit, ultimately tracing out a kind of spiral pattern. By an incredibly small amount, 43 arc seconds, about 1/100th of a degree per century. When Einstein performed his calculation of the orbit using his theory of general relativity, the number came out just right. As described by Einstein's biographer, Abraham Pais, this discovery was, I believe, by far the strongest emotional experience in Einstein's scientific life, perhaps in all his life. He claimed to have heart palpitations as if something snapped inside. A month later, when he described his theory to a friend as one of incomparable beauty, his pleasure over the mathematical form was indeed manifest, but no palpitations were reported. The apparent disagreement between general relativity and observation regarding the possibility of a static universe did not last long, however. Even though it did cause Einstein to introduce a modification to his theory that he later called his biggest blunder. But more about that later. Everyone, with the exception of certain school boards in the United States, now knows that the universe is not static, but expanding. And that the expansion began in an incredibly hot, dense Big Bang approximately 13.72 billion years ago. Equally important, we know that our galaxy is merely one of perhaps 400 billion galaxies in the observable universe. We are like the early terrestrial map makers, just beginning to fully map the universe on its largest scales. Little wonder that recent decades have witnessed revolutionary changes in our picture of the universe. The discovery that the universe is not static but rather expanding has profound philosophical and religious significance because it suggested that our universe had a beginning. A beginning implies creation, and creation stirs emotions. While it took several decades following the discovery in 1929 of our expanding universe for the notion of a Big Bang to achieve independent empirical confirmation, Pope Pius XII heralded it in 1951 as evidence for Genesis. As he put it, quote, "It would seem that present-day science, with one sweep back across the centuries, has succeeded in bearing witness to the august instant of the primordial fiat lux, let there be light. When along with matter there burst forth from nothing a sea of light and radiation, and the elements split and churned and formed into millions of galaxies. Thus, with that concreteness which is characteristic of physical proofs, science has confirmed the contingency of the universe and also the well-founded deduction as to the epoch when the world came forth from the hands of the Creator. Hence, creation took place. We say, therefore, there is a Creator. Therefore, God exists." The full story actually is a little more interesting. In fact, the first person to propose a Big Bang was a Belgian priest and a physicist named Georges Lemaitre. Lemaitre was a remarkable combination of proficiencies. He started his studies as an engineer, was a decorated artilleryman in World War I, and then switched to mathematics while studying for the priesthood in the early 1920s. He then moved on to cosmology, studying first with the famous British astrophysicist Sir Arthur Stanley Eddington, before moving on to Harvard and eventually receiving a second doctorate in physics from MIT. In 1927, before receiving his second doctorate, Lemaitre had actually solved Einstein's equations for general relativity and demonstrated that the theory predicts a non-static universe, and in fact suggests that the universe we live in is expanding. The notion seems so outrageous that Einstein himself colorfully objected to the statement, "Your math is correct, but your physics is abominable." Nevertheless, Lemaitre powered forward, and in 1930 he further proposed that our expanding universe actually began as an infinitesimal point, which he called the primeval atom, and that this beginning represented an allusion to Genesis, perhaps a day with no yesterday. Thus, the Big Bang, which Pope Pius so heralded, had first been proposed by a priest. One might have thought that Lemaitre would have been thrilled with this papal validation, but he had already dispensed in his own mind with the notion that the scientific theory had theological consequences, and had ultimately removed a paragraph from the draft of his 1931 paper on the Big Bang, remarking on this issue. Lemaitre, in fact, later voiced his objection to the Pope's 1951 claimed proof of Genesis via the Big Bang, not least because he realized that his theory was later proved incorrect. Then by the Roman Catholic claims for Genesis might be contested. By this time, he had been elected to the Vatican's Pontifical Academy, later becoming its president. As he put it, "As far as I can see, such a theory remains entirely outside of any metaphysical or religious question." The Pope never again brought up the topic in public. There is a valuable lesson here. As Lemaitre recognized, whether or not the Big Bang really happened is a scientific question, not a theological one. Moreover, even if the Big Bang had happened, which all evidence now overwhelmingly supports, one could choose to interpret it in different ways depending upon one's religious or metaphysical predilections. You can choose to view the Big Bang as a suggestive of a creator, if you feel the need, or instead argue that the mathematics of general relativity explain the evolution of the universe right back to its beginning without the intervention of any deity. But such a metaphysical speculation is independent of the physical validity of the Big Bang itself, and is irrelevant to our understanding of it. Of course, as we go beyond the mere existence of an expanding universe to understand the physical principles that may address its origin, science can shed further light on this speculation, and as I shall argue, it does. In any case, neither Lemaitre nor Pope Pius convinced the scientific world that the universe was expanding. Rather, as in all good science, the evidence came from careful observation. In this case, done by Edwin Hubble, who continues to give me great faith in humanity because he started out as a lawyer and then became an astronomer. Hubble had earlier made a significant breakthrough in 1925 with the new Mount Wilson 100-inch Hooker telescope, then the world's largest. For comparison, we are now building telescopes more than 10 times bigger than this in diameter and 100 times bigger in area. Up until that time, with the telescopes then available, astronomers were able to discern fuzzy images of objects that were not simple stars in our galaxy. They called these nebulae.